Hi, cohort.
This is the last video of the week. Last week we learned two hypothesis tests. One was for a two-sample t-test, which I've already posted on, and the other one was called matched pairs, or in other words, dependent samples. So just a couple of slides by way of background. The way you know you're doing a dependent sample problem and then a matched pair problem is that each observation in one sample has a matched observation in another sample. I think in educational research, this most often appears in pre-test, post-test data that you might see. So with a matched pairs test or dependent samples test, what you're going to do is for each pair, you're going to make the difference. In other words, going to subtract. And that difference is going to be what you run the t-test on. For your null hypothesis is always that the average of the differences. That's what this symbol here means with the average and then the d differences. That the average of your differences is equal to 0. In other words, there's no difference between the pre and the post test. These are the three options you have for your alternative. If you think scores went down or things got worse, you'd have this one, a less than sign. If you think well, it depends actually, I take that back. If the average of the differences is less than 0, greater than 0, or not equal, the way you determine which sign you're going to use is you're going to find an example of the claim in your data. And I'll explain as I do the homework problem. Okay, so speaking of the homework problem, let's give that a try. Okay, so we're going to take a look at number 12 from the homework. And so it's here, it says, you wish to see whether students perform differently on essay tests and on multiple choice tests. So what they're going to do is they're going to give the students an essay test, and they're going to give the students a multiple choice test, and then they're going to see if their scores are different. Okay. So in this case, because you're just testing is there a difference, the alternative hypothesis is going to have a non-equal sign in it. If you wanted to figure out, for example, if multiple choice is better than essay, you'd find an example of a student that was truthful. So let's take a look right here at student A. See, student A did a better job at multiple choice than at essay. If you took essay minus multiple choice, you get negative 2. 43 minus 45, negative 2. Negative numbers are less than 0. So if you thought that multiple choice was better than essay, the alternative hypothesis would be that the average of the differences is negative. In other words, the average of the differences is less than 0. If you thought essay was better than multiple choice, for example, let's take a look at student E. See how his essay score was better than his multiple choice score? If you did essay minus multiple choice, you get a positive number. 30 minus 28 equals positive 2. Then the alternative would be that the average of the differences is positive. In other words, the average of the differences is greater than 0. But in this case, it simply says, do the students perform differently? And so you're simply asking, is there a difference in the means? Is the difference, average of the differences, not equal to 0? So let's go ahead and get started. The first thing we always want to do is we want to write our null and alternative hypothesis. So in this case, our null hypothesis is that the mean of the differences
Is equal to
0. The alternative hypothesis is that the mean of the differences
is
not equal to 0.
all right. Once that's
That's written, you're ready to do the test. So let's take a look at our data. And what we're going to do is we're going to put this data into our calculator. And specifically, what we're really looking for are the differences. So let me grab my calculator here. Okay, here it is.
so what I
What
want
I
to
do is I want to put the data, the differences that is, in my calculator. So I'm just going to come here, and the first pair is 43 minus 45. I can just subtract it right here. And I'm going to put the difference, -2, into my data. That's the difference of the scores. For the next student, it's 39 minus 33. And I'm just going to keep on doing this for all the data from student A through student H. So just give me a second while I get that in my calculator.
Okay, I can see
I messed up on this student right here, so I'm trying to figure out what student that is. Oh, and it looks like I messed up on the student above it too. Okay, so that's student number 4. That's student D. So this is supposed to be 47 minus 49. That's better. And this one is supposed to be 30 minus 28.
and that's
22. But now I'm worried because the next one should be a positive 3, so, bummer. Alright, let me check my data from the start. Sorry, one moment while I do that. Okay, the first one, -2, check. The next one is 6, check. The next one is -2, got it. The next one's also -2, got it. This one's a positive 2, that's true. This one should be 46 minus 43, which is a 3. I'm going to change that to a 3. The next one is supposed to be 34 minus 36, that's going to be a -2. And the last one is supposed to be 41 minus 37, and that's going to be 4. Okay, so 8 pieces of data and 8 students. Looks like we're good to go. Okay, so all I'm going to do is run a t-test on this data. So stat, test, plain old everyday t-test, not a t-cent t-test, just a plain t-test. I have data in my calculator. The number in my null hypothesis, remember that's what this means, is 0. My data is in list 1. I have a not equal sign in my HA, so I'm ready to go. So again, we're going to sketch the distribution and give me a t-score and a z-score, excuse me, a p-value. I see a lot of students, so I can tell my p-value is large. Alright, so here it comes. My test statistic is 0.75 and my p-value is 0.47. With a p-value this large, you're not going to reject your HA. Okay? So we're going to come over here and we're going to record our answers. So our test statistic is 0.75 or 76. We'll just round that off. We're not even one jump away, and you can see that on the graph here. So we're not even one jump away from our mean, so it's not unusual. So there's not enough evidence to conclude that there is a difference between the scores. Multiple choice, essay, it's all the same. Now, if I take a look again at this, that's not it. If I take a look again at the homework, notice they asked a couple of different questions. So set up the statistical hypotheses, we did that. Part B, I recommend just skipping it. The only point of calculating those values, and you can see the formulas in the book, they're really tedious. The only point of calculating those values is to give you your test statistic. Since we already know our test statistic, there's really no point in calculating these. We perform the test, and we do our final conclusion. No difference in the two approaches. Okay, that's it for this week's homework. Just email me if you have any questions. Hope that helped.